And today we look at one of the greatest things in all of algebra, the great and marvelous quadratic formula. Oh, yes. Which your pre-calculus teacher, your calculus teachers, all of your college math teachers will expect you to know. And it's not hard. Let's do it. Oh, yes, we're skipping section 8 too. We just don't have time to do everything, so we're not doing that. All right, let's take this. ax squared plus bx plus c equals 0. The standard form for a quadratic equation. Old stuff from the first section of this chapter. Let's solve it for x.
Say what?
Yes, solve it for x. How are we going to do that? We are going to complete the square.
But there are no numbers.
Oh, be serious. They're all numbers. A is a number, x is a number, b is a number, c is a number. They're all numbers. Let's just complete the square.
Okay, if you say so.
Yes, I do say so. All right, what's our first step? Well, remember, you have two options for a first step here. You can either get rid of the a first or get rid of the c first. It is entirely your choice. I think in most of the book's examples, they start by getting rid of the a. So let's do that. How do we get rid of the a? Same way we've always gotten rid of a coefficient. We divide everything by it. We divide both sides of the equation by a. So what happens? Well, ax squared divided by a is just plain x squared. Bx divided by a is, well, just that. It's bx divided by a. And c divided by a is what? How about c divided by a? C over a. Equals 0 divided by a, of course, still just 0. Oh, that wasn't hard. Now you remember that the next step would be to get rid of the c over a, because right now it's just bothering us. It's in the way. It's not what we're looking for. So we're just going to get rid of that c over a. So let's subtract c over a from both sides. We have now x squared plus bx over a, just bringing this stuff down. But I'm subtracting c over a from both sides. This is so much fun. I haven't done this since last year. Now, our next task is, just like it has been before, our next task is going to be to complete the square. What goes here? What's our procedure?
Well, we're supposed to take half and square it.
Yeah, take half of that coefficient.
But there's nothing to take. There are no numbers.
Hey, come on. These are numbers. How do you take half of a fraction? Remember the shortcut trick that I showed you before? To take half of a fraction, all you have to do is double the denominator. So if I take, let's do it in white, if I take b over a, and take half of that, that'll give me b over 2a, and then square it, what do I get? I get plus b squared over 2a squared, which is 4a squared. I have completed the square. I took half of b over a, which became b over 2a, and squared it, which was b squared over 4a squared, and added it. Oh, I haven't added it over here. That's serious. We're going to add it over here as well. But tell you what, let's rearrange things a little bit. Let's move this guy. Oh, I don't want the equal sign. Ungroup. Okay. Let's just move that over a... Whoops, I didn't mean to rotate. Goodness, no. Let's take all of this and move it, there we go, over here. And we'll... I need to move it further. That wasn't far enough. And we're going to, because we added b squared over 4a squared here, we also need to add b squared over 4a squared over here. Now remember, I've said in the past that factoring this is trivial. Factoring this is always easy because we rigged it to be easy.
Well, how do we do it this time?
Oh, we do the same thing we've done before. It's just as easy as it had been before. I'm going to have something squared. X goes here, match the sign, And what was squared here?
Oh, I see. B over 2a.
Mm-hmm. B over 2a. We factored. Just as easy as it's always been. Because we rigged it.
Are you allowed to rig things?
In math, yes, you can rig things. Now here, we got a little bit of work to do. We need to put these fractions together. We need to combine these. We need to do the subtraction. But to do that, we need common denominators. This might be the hardest part of all, but folks, really, it's not hard. We just need common denominators. What am I missing over here? Well, here I've got an a squared. Here I only have an a, so I need to multiply by another a there and an a here. And I've got a 4 there that I don't have here, so I'll multiply by 4 and I'll multiply by 4. Now I have common denominators. Now I can subtract my fractions. That's elementary stuff. So what do I have here now? B squared minus 4ac, all now over 4a squared. Nice. All right. Well, with all the other problems we've done on completing the square, what was our next step? We take the square root of both sides. Same thing as before. Taking the square root of this thing, we end up with just x plus b over 2a. No problem. On this side, a little ugly, but it's going to be the square root of, oh, watch out, I almost forgot, plus or minus, let's move that equal sign over, plus or minus the square root of b squared minus 4ac all over 4a squared. Now, let's simplify this thing. Let's just tell you what, let's move it. I want to get it over toward the center of the board. There we go. Alright, so let's just copy this part down. X plus b over 2a equals. Now, simplifying this, there's one thing and only one thing we can do. We know the square root of 4a squared. So this becomes plus or minus the square root of what we're left with up here, b squared minus 4ac. Can we take out the b squared? No, you can't take out the b squared. There's a minus here. You can't do that. Come on. And it's now over. We have taken out the 4a squared. It becomes a 2a. We've got two little details left to take care of. We have not quite solved for x yet. This is in the way. Well, let's just subtract it away. So now x equals, and congratulations, we have now gotten x by itself. Isn't that awesome? We did it. But of course we have to finish off the process. We're subtracting b over 2a. I'm going to put it right here like this, b over 2a plus or minus the square root of b squared minus 4ac over 2a. Just copying all this stuff down here. Ooh, look, I have common denominators. Cool. If I have common denominators, I should be able to combine the numerators. Sure enough. So now we have, need some more space here, one moment. Okay, so now we have x equals, all right, put the numerators together. That'll be inverse b. Notice how I say inverse b, not negative b. If you call that negative b, it increases the likelihood that you're going to mess up. We don't know if this is positive or negative. If b is positive, then inverse b is negative. But if b is already negative, then inverse b becomes positive. So if I don't know if it's positive or negative, why do I call it negative? I don't, and you shouldn't. Inverse b. Or I think our book says to call it opposite of b. Opposite of. That's too many syllables. I prefer inverse. Inverse b. Inverse b plus or minus square root of b squared minus 4ac. All now, because we're combining our fractions, all now over 2a. Folks, that is one of the most famous formulas in all of mathematics. This is what your pre-calculus and calculus teachers will expect you to know. If they say to you, hey, prove to me you know the quadratic formula. If you go, oh, it's x equals something, it involves a square root and there's a b in there someplace and a fraction, they will laugh you right out of the room. You'll be expected to know this. X equals inverse b plus or minus the square root of b squared minus 4ac all over 2a. Say it yourself 10 times, you'll have it. Hey, say it with me. X equals inverse b plus or minus, oops, I just messed up because I closed my eyes. X equals, no, I think I was doing it right. Anyway, x equals inverse b plus or minus square root of b squared minus 4ac all over 2a. X equals inverse b plus or minus the square root of b squared minus 4ac all over 2a. X equals inverse b plus or minus the square root of b squared minus 4ac all over 2a. Know it. And use it. Examples. All right, here it is. Hey, that looks familiar. X equals inverse b plus or minus the square root of b squared minus 4ac all over 2a. Let's try it on this guy. This would be easily factored. We could solve this by factoring with great ease. But we're going to use this simple example as our first example of how to use the quadratic formula. So we just fill in the blanks. We're going to have x equals inverse b. Where is b? That's a, that's b, that's c. Oops, I forgot. That's not even an equation. There's nothing to solve here. It's not an equation until I set it equals 0. Sorry about that. Hopefully somebody out there in TV land noticed that. And you say, Mr. Bear, you forgot the equals 0. Yeah. If it's not an equation, then there's nothing to solve. Now there's something to solve. All right. So we have A, we have B, we have C. So we start off with the opposite of b, inverse b. That's going to be negative 10 plus or minus the square root of b squared. That's 10 squared. That's 100. Minus 4 times a times c. 4 times 2 is 8 times 2 is 96. All over 2 times a. That's 2 times 2. That's 4. We're practically done. Now we just simplify. We got negative 10 plus or minus the square root of, look at this, 4. We know that one. Over 4. That gives me negative 10 plus or minus 2 over 4. How many answers is that? That's 2 answers. What are they? Negative 10 plus 2 is negative 8, divided by 4 is negative 4. And the other answer, negative 10 minus 2, which is 8. I'm sorry, negative 8. No, come on, Spirit. Negative 12 divided by 4 is negative 3. Did I just do something silly? Yes, I did. That first number, man, not enough sleep last night. My first one should have been negative 10 plus 2 is negative 8. Negative 8 divided by 4 is negative 2. That's better. Sorry about that. And there I go, messing up on the simplest part of it all. Let's look at another example. As always, we start with our friend. X equals inverse b plus or minus the square root of b squared minus 4ac all over 2a. By the way, that thing we did back in the beginning where we derived the quadratic formula by just completing the square. Oh, excuse me. Most likely you'll never have to do that again in your life. I just don't like to throw a formula at you without showing you why it's true. Well, we showed back in the earlier screen, way back here, we showed why it's true. We took the quadratic equation and solved it for x by completing the square, and we proved that this is true. But you'll never have to do that again. So, now where were we? Oh yes, we're right here. All right, so we're going to use the quadratic formula, but first, oops, you can't use the quadratic formula until this thing is in standard form. So we need to get that -1 to the other side. So we're going to add 1 to both sides. May I use the eraser? Thank you for your permission. So adding 1 to the other side, we have +1 equals 0. Okay, don't get messed up on that little detail. You have to have the whole thing equal to 0 before you start. So from there, x is inverse b. That's -5. Plus or minus the square root of what? B squared. That's 25. Minus 4 times a times c. 4 times 3 times 1 is 12. That's all over 2 times a. 2 times 3, that's 6. From there we just simplify. Oops, don't look at the answer. So what do we have now? -5 plus or minus the square root of 13 over 6. Because that's irrational, we're done. Yeah, we could plug it into a calculator and get our 2 approximations. But we're done. Yep, -5 plus or minus square root of 13 over 6. Done. See how easy that is? This would not be factorable. How do I know it's not factorable? Because we get irrational answers. That tells me it would not be factorable. Okay, there was something that shot through my mind. Oh yes, a possible complication. Suppose we had, I'm changing it now. Suppose we had an example that had, instead of a +1, a -1. What would the difference be? There'd be one and only one small difference. The only place where c shows up is right there. So what would that do to us then? We would have b squared minus 4 times a times c. That's minus 4 times 3 is 12 times -1 is -12. Minus -12. How do you subtract -12? Minus -12 becomes +12. That's a major source of careless error on these kind of problems. If one of these guys is negative, that minus 4ac will turn into a plus. Watch out for it. Be careful. So our final answer would be, what, 27 square root of 27. And we'd be done. No, not 27, 37. I forgot what the numbers were now. It was 25 plus 12, yeah, 37. Sorry about that. Like I say, not enough sleep. Okay. We have another example here. This time, what's A? Yeah, A is 1. What's B? B is also 1. What's C? C is also 1. Well, this one should be really easy because everything's 1. Yep, I would agree. X equals inverse B, that's -1. Plus or minus square root of B squared, that's 1. Minus 4 times 1 times 1, that's -4. All over 2 times 1, that's 2. We get -1 plus or minus square root of, -3 over 2. It's going to be imaginary. Pop the I out, that's expected. Popping the I out, we have -1 plus or minus I square root of 3 over 2, and we are done. That's it. Your assignment. Page 352. Numbers 2 through 24 even. Some of these, not many, but some of these could be done easily by factoring. Don't factor them. You are expected to use the quadratic formula on all of these, and obviously your work must be shown. And in conclusion, the quadratic formula. Behold its beauty. In fact, let me step completely out of the picture here and let you just focus on the beauty of that formula. X equals inverse B plus or minus the square root of B squared minus 4AC, all over 2A. Beautiful. All right. Assignment due when? This is Friday. The assignment's due Monday. Then we'll have a review assignment. And after the review assignment, we'll check the review assignment on Wednesday. And the test will be Thursday at 1 o'clock. Thursday at 1 o'clock. Be there or be square and take a 0.